I asked ChatGPT for a definition of what security research is. So I try to add with my own words a little bit, compared to like actually trying to find vulnerabilities. In security research, you're not necessarily looking for security issues because you're maybe looking just for potential security vulnerabilities. I think this applies a lot to frameworks and libraries because you don't know how somebody will use the library. For example, a library that allows to spawn processes can be implemented correctly and it will be fine, or incorrectly and you have remote code execution. So in this case, I want to have a look at the VSCode language server implementation. Specifically in the JSON RPC protocol, I noticed there's something during a client review, and I thought it would be fun to further investigate it. And that's what we are going to do. We will set up a basic sample project, and then we just poke around and play around with it and see if we can find something. So that's the plan for today. Okay, so I think there are a few steps. Let me see. I try to think about now, as a viewer, how would I like this to be structured that it's somewhat nice to follow? Because if I would do this now just by my own self, I would just, I don't know. I need a bit more structure, I think, if I want to make this more useful for other people. And also, I lack structure in my own research process. So maybe this... So I want to try like force myself to some structure and better documentation, which I usually don't do, to see how this if that helps me and what the result is. If I feel like I'm more efficient, if I would actually invest time into documentation and more structure and stuff. So let's see, how would I do this? Let me switch over the screen. Let me turn on music again. There we go. So we get into the flow. Reading some code. Okay. I think, where's it? Okay, so here's my desktop overview, which makes me extremely paranoid because I'm scared of leaking stuff. Do I have already something bad open? I guess, hopefully not. Music down a little bit, of course. How is that? So I have this repository that we started, oh my gosh, 7 months ago. It's called Security Research. It's a repository where I want to start adding results of security research. So why not document this within this repository as well? I guess we start with adding a folder. So how would I call this? Maybe research notes, and then let's just call it what it is. I guess it's VSCode language server, VSCode JSON RPC. Rename. I think it's called LSP in the official. I want to specifically look into VS Code JSON RPC, so let's call it maybe that. Okay, so I think what we first, how would the research process generally look like? First, I guess we set up a basic language server example to look at it, and then I already know in what area I want to look at. So this is already a little bit of I guess I know already a little bit where this is going to, which is investigate the process communication threat surface. This will make sense for you in a moment. Once we stop, we will I want to structure this in a way as if we do the research. So I will tell you in a moment what this, how we come to this kind of conclusion to look into that. Code review of JSON RPC implementation. Can we find vulnerable implementations? Okay. All right. So I think we should start with setting up a basic language server example. There is an example repository. The reason for that being is usually when you, or like how it was for me, we had a client and there was something about, VSCode language server stuff, and which meant I had to look into it. So I had already an example project to work on, which was the client project. Of course, I cannot show this. I don't want to show this. It's completely separated. This is not like my personal like work stuff, and I don't want to I already feel icky even like talking about it like in this complete like anonymous way, because I feel like there should be a strong separation between like live overflow stuff and my other work stuff. But I want to do more of this research stuff. I feel like it's probably going to be okay because I'm not like talking about anything. So so we need like a base project to kick off the research. We need an example because the VS Code language server framework and stuff is, it's a library. It's a Node.js library that you can use to implement your own VS Code extension and VS Code language server. What that is, we will figure out in a moment. But I'm just saying, like, this is the library, and we need an example to understand how this library is used. And we can usually it's good to start with like a big program like that's using it, so you see like a lot of different ways of how it's being used, or like an example implementation. These are good starting points to do security research, because you need a way to figure out like what is a common way how it is used, because as I said, as an example, you can have a library that executes a child process and implement it correctly and safely, it's fine, but implemented incorrectly and you have remote code execution. Saying, oh, this library has a security issue is bad, because it depends on the way how you implement it. However, there are ways how the library can make it like easy to implement it securely, and there are ways how it could be easy to make mistakes. And then maybe we like want to comment on, oh, this is like implemented in a insecure way or in a good way or not. And then once we identify ways how you could easily make mistakes, we can then start looking for projects that maybe made this mistake. But you'd never know this. But that's like a good start. And it's not necessarily vulnerability. It's just, you could make a mistake, and this mistake then becomes the vulnerability. So I also like speaking ethically about exposing, like doing this on stream and maybe discovering something. I think to me this is totally fine. It's not a high risk target or anything like this. And again, it's not necessarily vulnerability in itself. It's always like in combination how it was, if it was implemented correctly, whatever. Okay. Let's head into it and let's figure out what even is a language server extension. Like what even am I talking about? And let's read a little bit here the Visual Studio Code extension guide. I have not really read this myself, so I probably will learn a bit. Like for me, this is also learning. Like I didn't spend a lot of time. I'm here on stream. I want to spend this time with everybody, like learning together. Like of course I have a few like things that I know of. Now I lost. Wait. God damn it! Where's my window? I lost the stream dashboard. I think I accidentally closed it. There's a delay between my voice and audio. It's fine for you. Okay, then maybe refresh the stream and tell me again. But okay, let's test this. Okay, can you tell me? I will clap and then you can visually see if there's a delay. Careful, there it comes. Let me do another clap. All good. Okay, good. Then it's probably Okay. Okay. All right. Okay. So let's read this here. Here, if you want to read along, let me share you. I'm drinking, of course, the drug that helps us do better work, Club Mate. Okay, as you have seen in the programming language feature topic, okay, we didn't read this, it's possible to implement language features by directly using the language API. Language server extension, however, okay, so by the way, I have basically zero experience with Visual Studio Code extensions and so forth, right? But how do I explain this? I mean, all of you know this about learning. You are all experienced programmers and stuff. Like you know that you start with knowing nothing, and then you start with one thing, and then you slowly build up the mind map of how everything works, and you slowly piece together the different puzzle pieces to get a bigger picture. So for us, this is like the entry point. If it's a good entry point or not, we don't know yet. But whatever. Language server extension, however. So we are talking here about a specific VS Code extension. You can develop Visual Studio Code extensions, but we are talking now about another a specific type of extension, which is called a language server extension. So just maybe this helps a little bit. We will figure out. I found the language server it's like one of those things that I heard and I had no clue what it means. So if you feel that way, don't worry. I think we will figure out in just a few moments what it means. For now, just this term you will understand in a moment. Okay, this topic explains the benefits of language server extensions and walks you through building a language server using the language server node library. You can also jump directly to the code in the sample. And this sample I want to base on the testing. Okay, so why a language server? So now here you understand what it's about. Language server is a special kind of Visual Studio Code extension that powers the editing experience of many programming languages. With language servers, you can implement autocomplete, error checking, jump to definition, and many other language features supported in VS Code. However, while implementing support for language features in VS Code, we found three common problems. First, the language server are usually implemented in their native programming languages. And it's a challenge to integrate with VS Code, which has a Node.js runtime. Additionally, language server features can be resource intensive. For example, to correctly validate a file, a language server needs to parse a large amount of files, build up the syntax tree, do static program analysis, and these operations could incur significant CPU and memory usage, and we need to ensure that VS Code's performance remains unaffected. Finally, integrating multiple language toolings with multiple code editors could involve significant efforts from language tooling perspective. They need to adapt to code editors with different APIs. From code editors' perspective, they cannot expect any uniform API from language tooling. This makes implementing language support for M languages and code editors a lot of work. To solve this problem, Microsoft specified the Language Server Protocol, which standardizes the communication between language tooling and code editor. This way, a language server can implement in any language and run in their own process to avoid performance cost, as they communicate with the code editor through the Language Server Protocol. Furthermore, any language server protocol compliant language tooling can be integrated with other language LSP compliant code editors. So you here see the picture. So if you have an editor like VS Code or Vim or IntelliJ or something like this, and you won't have auto-completion, syntax checking and all that stuff, that IDE, that editor needs to implement that somehow. Some languages maybe provide this as a feature and it can be integrated and so forth, but in VS Code there's a standardized way how to do it. The idea is that then also other editors benefit from it. So if an editor implements this API, they can use the language server that were already developed and integrate them in your editor, and you can get all these features of auto completion and whatnot. So this is, there's a question, language server protocol is different from extension, I think. Well, basically, so, I mean, yes and no. You have VS Code extensions and you have a language server. Like, they are two different pieces, basically. So you have, like, here on the left, basically the language server for Python or JavaScript or Java. And on the right, you have your VS Code program. But you might have, like, you maybe create you create your own extension, VS Code extension that communicates with your language server. So I would say a VS Code language server like is a language server in itself is something else, but in this context here, a VS Code language server is like a special kind of extension. It's an extension with a language server added to it. Okay, so this guide, we will explain how to build a language server, a language server extension in VS Code using the Node SDK, how to run and debug it, and point you to some advanced topics. In VS Code, a language server has two parts. I guess this explains it now. There's a language client, which is a normal VS Code extension that is written in JavaScript or TypeScript. And this extension has access to all the VS Code APIs. So you create a VS Code extension, and then you have a second part to it, which is the language server, which provides all the language analysis. It does the syntax checking, the references, the cross references, I don't know, whatever crazy features you want for your programming language. So every time your IDE tells you about a syntax error, and maybe also does the syntax highlighting, I'm not sure. All this stuff, it's actually communicating with a code, like a server, a small utility that provides this kind of information. So somebody, of course, had to implement the code, this logic to do all that, and that's implemented in the language server. As briefly stated above, there are two benefits of running the language server in a separate process. Yeah, so here you can see like how it works. So you have VS Code, inside of it you have the the extension feature stuff, and maybe you have a HTML language client or a PHP language client. So these are two different VS Code extensions that provide these language features, and they communicate through the language server protocol, which is a JSON RPC protocol, with their respective language servers. This guide will teach you how to build a language client server using Node.js. The remaining document assumes that you are familiar with the VS Code extension API. We are not familiar, but let's see. Let's see if we can just get it to work. And now I want to set up this basic example here. Let's build a simple language server extension that implements autocomplete in diagnostics for plain text files. We will also cover the syncing of configuration between client and server. If you prefer to jump right into the code, by the way, do you hear the noise from upstairs? Do you hear that? It's like this. Do you know this video? I love it. It's one of my favorite YouTube videos.
It means we make sound.
People think of neighborly noise as a nuisance, but we think of it as an art form.
We want the sounds to be different, but completely unrecognizable.
It just sounds like bowling balls. That can't be what it is, but that's what it sounds like. It sounds like bowling balls.
That's what it was,
Is it
right?
a bowling
It was bowling
ball?
balls.
Is it a metal barrel? You never know, because sometimes we get metal barrels.
You knew we were twisted, though. Julia is a...
But I think we found the matching source. All right, okay. So I think I just want to take this example code and just like, instead of implementing myself, just let's, okay, there's also multi-server example, but let's just start with the basic example. Okay, so how do I do this? I need to quickly clone this code here. Give me 1 second. Grab the URL. Okay, it's a big repository because it has like tons and tons of VS Code examples. Look here, there's like so many examples, and basically we are only interested in this example here. Okay, okay, there we have it. Here, install ESLint. Never. Okay. Okay. So we have here the server and the client. Let's see what the text stuff, this explanation here said. Okay, so we clone this, and now we run npm install and npm run compile. Let's see if we can do that. Hopefully I have like everything like installed and stuff. Please let me have like Node and everything. Like I don't know how to fix Node stuff. What editor do you use? VSCode. Okay, so that seemed to have worked. npm run compile. Okay, the above installs all dependencies and opens the LSP sample workspace containing both the client and server code. Here's a rough overview of the structure. Explaining the language client. Let's first take a look at the package JSON, which describes the capabilities of the language server. So first look at the configuration section. The section contributes configuration settings to VSCode. The example will explain how these settings are sent over to the language server on startup and on every change of the settings. Interesting. Okay. If your extension is compatible with VSCode, you must declare, okay, whatever. The language client source code and the corresponding package.json are in the client folder. The interesting part is in the client package.json file, which references the VSCode extension host API through the engines field and adds a dependency to the VSCode language client library. As mentioned, the client implements a normal VSCode extension and has access to the VSCode namespace API. Below is the content of the corresponding extension file, which is the entry of the sample extension. We'll look at this in just a moment. And then, so this was the client. As I said, there's like a client, which is a VSCode extension, which then communicates with your VSCode language server. And so let's look at the server. In the example, the server is also implemented in TypeScript using Node.js. Since VSCode already ships with a Node.js runtime, there's no need to provide your own unless you have specific requirements for the runtime. The source code for the language server is /server. This pulls in the VSCode language server libraries. Below is the server implementation that uses the provided text document manager that synchronizes text documents. Below is a server implementation that uses the provided text document manager that synchronizes text documents by always sending incrementing deltas from VSCode to the server. Oh, it sounds like hell implementing a VSCode server. Adding simple validation. To add document validation to the server, we add a listener to the text document manager that gets called when the content of a text document changes. It is then up to the server to decide when the best time is to validate the document. In the example implementation, the server validates the plain text document and flags all occurrence of words that use all caps. Okay. We will look at this in just a moment when we also can debug this. If the start and end position are the same, VSCode will underline with a squiggle the word at the position. If you want to underline with a squiggle until the end of the line, then set the character at the end of the position. Press Ctrl+Shift+B to start the build task. The task compiles both the client and server. Open the run view, select the launch configuration and press start debugging. Create the test.txt file in the root folder, and then it should work. Okay, let's try this. So let's try to run this. So we have, what is it? Ctrl+Shift+B, Ctrl+Shift+B, and then open the run view, launch client. Okay, so we now get a new VS Code extension development host. So in here we should now have our, like our extension should be running. How can we see that? If you go to extensions, does it show like our test extension? Okay, not sure. Now we are supposed to create the test.txt file. Let's open a test folder somewhere. Okay, so apparently it worked. It flagged now all the uppercase letters. Okay, again, so quick recap. What did we do here? So apparently, like, let's keep that up here and let's look again at. Okay. So here's the example code that we execute right now. So we have a client which implements a VS Code extension. I guess here is how it's called. VS name LSP sample client, VS Code part of language server. And we have here an extension that does, I guess, the VS Code extension stuff. I don't know, like whatever. This is like the... okay, it's not too long. Okay, so what does it do? So on activate, I guess. Here is the server module in server out server.js. So where does it build it to? Out test. Whatever. Okay, so this is the server, the language server, I guess. That's the server module, and then we prepare server options with this server module path, and we use the IPC, inter-process communication, node IPC, as a transport between those two, between the client and the server. So we prepare these server options. I know this already because I looked a little, I've read a little bit of code around language server stuff. And then we prepare some client option as well, where we say we want to register the server for any plain text file. And then it also notifies us about the client RC file. I don't know. And then we create the language client and we start the client. We hand in, so language server name, I guess. And then we pass in the server and the client options and we start it. And that's it. Apparently, so basically the main thing is that we define a server and a client. The client defines what will be sent to the server, and the server defines like where it's running and how the communication is being done, and then starts it. And now we go to the server side. On the server, here we have a little bit more code, I guess. So we have here the server starts by listening. Listen on the connection. Okay, so we have a connection object here and a documents object. Documents is create a simple text document manager. Language server text document. Okay, yeah. All right, that's just how you do it. And then we have a connection object. I guess that's the more interesting one. So you create a connection with node IPC as a transport and with all features enabled. No clue what that means. So we have a connection on initialize. Something about workspace configuration and settings. I don't know, not that interesting for me, I guess. Workspace folders, and then connection. This was connection on initialize. Oh, with parents and without params. Okay, so if you call it without, uninitialize and uninitialized after it got initialized. Okay, whatever. This is just like event handlers basically for the different steps. So if the configuration changed, so if you get notified about setting changes, you get the change, and then you seems like, yeah, I don't know, you override like your global settings, like you update the preferences. And then what else do we have on close? Well, document settings. It's a map of all open documents. Okay, so I guess we will see like it get document settings. So if you have a string, you pass it in. Okay, so if you have like a document, I guess, open, it tries to get it, and if it doesn't get it, it creates it, whatever. It's just like, I guess, you know, housekeeping. Okay, on did change content. The content of a text document has changed. This event is emitted when the text document first opened or when its content has changed. All right, okay, so we have an event listener on that. So this is now done on the document. How is the document passed like to the connection? You have this VSCode text document manager, which exposes like all these different events, and you configure it with the connection. Okay, so I guess whatever, like there's a lot of abstractions happening. So as a developer, you don't need to care about the actual underlying protocol. You define, okay, you have a text document manager and you want to react on different text document stuff. For example, when a change happened to the text document, and then you call validate text document, and this does now the actual diagnostics. It gets the text, it looks for this regex pattern where it checks if all the words are uppercase, and this is the result. Then it finds all the uppercases, and then it creates like this diagnostics object and sends the diagnostics back to the client. And I guess, you know, we there was no like diagnostic handler on the client, because I guess this is like standard VSCode stuff. Like if you create like a diagnostics object like this and send this to VSCode extension, it will like create, you know, the squiggly lines with all the explanations of you know, this description here. Okay, so this is pretty cool. Now let's look at our like note taking. Set up a basic language server example. So we set up, so we followed this guide here, and we use the code, that's the wrong one, LSP sample. This here. Okay, so now investigate the process communication threat surface. Okay, so now like in terms of like security research, whenever you have a library or I guess any source code or so, you think about what is the threat surface? Like what could an attacker even do? And this is a very important step. Generally speaking, you know about this. Validate all untrusted input. It's easily said, but what is untrusted input? You need to understand like how even an attacker can like input data into here. Of course, you could like imagine that like maybe an untrusted document, like somebody copy and pastes text into your VS Code, and then this text is sent to the server, right? Like we know that here on invalidate document, you get the text and then it does something on it. And for example, here, I guess let's write test. See, I'm pointing at the screen as if you can see my finger on the screen. It, for example, includes here the test, this text here, and this could be untrusted, right? So theoretically, like, you know, what would happen if you have like script? I mean, it doesn't work because it's like, you know, because it's VS Code, it's like Node.js, it has like HTML and everything. So there's a potential for XSS, for example. So this is a threat surface, but this is a threat surface. Now I have to think about, is this related to the VS Code extension itself, or is it related to the VS Code and the language server, or is this related to, you know, VS Code itself? And now this attack surface of you know, being able to have like here control text, that is VS Code related stuff. Like if you isolate like the extension, the VS Code language extension client and server that we just developed, this is not part of it. This is part of VS Code, official VS Code, and you need to prioritize now. And, you know, looking at VS Code, this being a standard like feature of it, my initial reaction is, I assume this to be safe. Like we couldn't inject anything here. I mean, we can try it. So we could easily change, you know, change our regular expression to allow like also lowercase. Oh, yeah, I don't know, like this maybe. Then restart. Okay, now it matches like everything because it's also matching lowercase. Let's see if does it match now H1. Am I an idiot? Why does this not match? Am I an idiot? Why does it match? Why does it not match this? Why does it match like closing? Oh, does not include numbers. Good point. This is pretty sleek. I press like restart and the new, bam, the code is like we can test it immediately. It's pretty nice. Okay, H1. But why does it not include the... Wie kriegst du deine Notizen live formatiert? How do you get your formatted? This I'm using Obsidian here. Obsidian MD, which does like Markdown. So you're creating Markdown files. Alternatively, if you use you know, text documents and you use, for example, VS Code, you can also do like Markdown. I guess you have to install an extension for it. Install like a Markdown preview, and then you can have like two panes, like left your text and right your formatted one. It wants word boundary. Oh my gosh, yeah, I'm a regex noob. So this doesn't count as word boundary. Okay, then let's do spaces, I guess. Oh, space at the start. Okay, now we got it. So you see here, like, there's no injection happening also, right? But this is, of course, still, you did like a little bit of security research. You tried if like a malicious VS Code extension or a malicious text document where the information is like included in this field, like can't do anything. But I mean, it was completely like I would have taken on a bet that this doesn't work just because, you know. Anyway, so I wanted to say, like, if you think about untrusted input and where, like, what's the threat surface? This is the threat surface of VS Code itself. This is not the threat surface of the VS Code extension or language server stuff. So what other threat surface is there? Of course, we get the text document here, and something could like be bad in here. Like if there's like literally code that would be like take text and eval it, you know, like eval text. Now you have a vulnerable VS Code extension because you just take the document text that is coming in and you eval it. This is obviously a dumb example, but language servers, I guess, can be very complex. You know, maybe you want to automatically evaluate calculations or something. You know, something like this, that it automatically matches it. Like we could write an extension that now matches text like this and tells us the solution or something like this. And then depending on, maybe this is passed into like a Node.js interpreter or Python or something like this, you know, like there are ways how this could be vulnerable. So this is definitely a text surface for a VS Code language extension where you need to think about like how this comes in. In most cases, it's probably like, it's very rare. Like it must be a very weird language server that this kind of untrusted input does anything. But theoretically, it's threat surface, okay? So maybe we should take notes of that. Investigate the threat surface. We have document data, for example, sent to the language server. Okay, so this is example, but I want to get to it something else, which I mentioned previously. It's a communication. So communication between different components is always communication between components is always a super interesting area for like security research and auditing, because the question is like, these are different components. How do you ensure that only this component can talk to this other component? And is there a way for something else to communicate, you know, with your components, like being a malicious, acting as like a malicious component? Now, in this example case, it's already uninteresting, so to say. Like it's implemented here securely. What I'm specifically, basically securely. What I'm specifically interested in here is the transport kind. The transport kind is IPC. And so this is where like the code review of the VS Code language server code starts. So let's go to the language server implementation here. So this is, so if you look up, so basically, if you look up here the dependencies, I guess a package log. No, wait, what was it called again? VS lang. Okay, so if you look here in the, for example, in the server, you know, if you search for this, then you end up basically in one of, I mean, this is now VS Code JSON, obviously, but basically this npm, and then you can find the repository where this code lives. So this is the overall repository, and it contains multiple modules. It contains the code for the client, the server, this text document that we just used, the language server protocol, language server types, and JSON RPC. Moro, I'm not quite sure what you mean. In hardware, you can connect and read all data, period. Well, the thing about JTAG, which you mentioned earlier, is about that inside a chip, you cannot easily connect it. And chips are quite complex. They might have data and code running and so forth. You can like easily measure the external pins, but you cannot measure like the internal like information. And if you have like a secure chip, like in a credit card or something, or a SIM card, then everything is like on this integrated chip. You cannot like easily read out the memory. You cannot like easily connect wires to the memory cells or something. And this is where then open JTAG, when the chip allows to connect to it with JTAG or so, could be a problem, because then you can very easily access the data. Of course, theoretically, you can open up the chip with like a microscope and like use like in a destructive way, and then use ions or something, I don't know, like to read out the chip memory cells or something. But you're talking millions of dollars in cost for equipment and stuff like this, you know. So you want to raise, it's always about raising the bar, right? Like even computer security, like software security, it's about raising the bar, because in the end everything is running on hardware. You can always come in, point the gun at somebody and tell them to unlock their computer and give you the data, right? But the bar is so high to do that, so that's why it won't happen. And so if you have a chip and it's locked down, JTAG not exposed, and there's data stored inside that chip, it's very hard to get to. It's probably good enough. So, you understand? I want to focus now on the language server stuff. Okay, like if you have like a good formulated question, I'm happy to answer. But like back and forth and stuff like this, it would be too distracting now from this project here. Where was I? Okay, so this is the code, the implementation of the library stuff. So we can have a look at this. So I don't have, okay, I have an account on here. Okay, so we can press dot to get the nice IDE, and then we can browse the code in here. Or let's come back again to this server implementation, or the client implementation rather, about the communication. So communication is important. So now the question is, so okay, wait, let me get Paint up. I guess no, let me get Photoshop open. Let's make a quick like sketch what I mean, so that it's maybe a bit clearer about thread surface stuff. Okay, so we have two components, right? We have the VSCode client extension, but extension, and we have the VSCode language server. Lang server, and they communicate somehow. And because they are two components that are trusting each other, it always depends on the protocol, like what is implemented there. So for example, VSCode clients, they can have web views, and web views could be implemented in a secure way. And maybe the VSCode client trusts the language server. So when the VSCode language server says, here, can you render this HTML for me, please? And then it's rendered in a web view, that could be an issue. Same same way the other way around. Like maybe the language server is evaluating code, like I mentioned earlier, the calculation example. Maybe this is a feature you want in a language code extension, and when you open an untrusted document in VS Code, it warns you. Are you sure you want to open this untrusted document? So while opening untrusted documents is somewhat of a threat surface, maybe you explicitly have a code extension that does very privileged stuff, like run another program or send API requests to something, or I don't know, like something. So there could be something where information traveling into that direction is doing something. Also, we now just looked at the VS Code standard APIs. You can also implement and add to the protocol. So maybe there is an exec program, like protocol message that is custom to this VS Code client and this VS Code language server, and this communication is trusting. But these are two trusted components, right? Like whether they are like, if like the VS Code extension itself executes something, or sends it to the VS Code language server and executes something, it's not necessarily a problem. The challenge is just this communication here, because the question you should ask yourself: can a malicious component talk on this communication thing? On the web, it's something very common, and that's something you usually you think about when you implement web servers, because you can think of this like as CSRF, for example. Like, can like one website send a HTTP request to something else, or generally API endpoints, HTTP APIs. Oh, hello, doggo. So yeah, if for example the language server is had like an HTTP API and is listening on local port 8080, then suddenly having a website, having like a Chrome browser. How does the Chrome logo look like? I guess something like this. Now you open a website, a malicious website, and it could send a request to localhost. And suddenly a website communicates with your language server and asks, hey, can you please execute this? Of course, there's no HTTP API, but I'm just saying communication and the way how server and client are implemented can be a threat surface. Now, in the case of our example here, we have the transport kind IPC. We will look in a moment what this means. But there are different ways how multiple processes, multiple components can communicate with each other. One kind is an HTTP API. There's IPC, there is raw TCP network sockets. There are other kind of pipes, like IPC could be, I don't know how IPC is actually implemented. It could be implemented through operating system pipes, so like Unix sockets or Unix domain sockets or something like this. There are lots of different ways how things could communicate. On Mac, it could be like Mac ports or whatever they are called. Like, there are different ways how one process can communicate to another. And this matters depending on what your threat surface is. So for example, I mentioned this in the server and client video, VPN clients. So usually, like any of your VPN ad stuff, like a VPN client, they have like a VPN client, which is running on your process as like your current user. But then it has to do networking stuff, right? It has to be able to hijack your network communication and route it through the VPN. So you actually have a VPN helper that is usually running as root on your local machine. And the VPN client asks the helper, start the tunnel, please. And then the root helper configures your network. So this is all happening on your computer, right? So, and this communication between, and this is generally a good design to separate, unprivileged client with the privileged helper, and let the privileged helper do only what is necessary for the thing. But what if more is implemented? So very typical VPN vulnerabilities are, for example, install this update. Because the client, communicates with the update server and sees, oh, there's a new VPN helper update. So it sends over the binary, hey, can you please update OpenVPN binary or something like this. And then the VPN helper installs it and maybe executes it. But what happens if a malicious program now, like a local virus that you execute as user, is now suddenly using the same communication and says, install this malicious update, and suddenly you have a local privilege escalation, right? So this communication matters, how this is implemented, and you want to make sure that that you have nothing like that if you provide, for example, updates, that you have like crypto signature checking to make sure, hey, is this really an update coming from our update server, or is this a malicious? I think you get the point. So IPC is generally something local on a computer, which means the threat surface is here, another malicious application. And here's the thing, probably the language server executed by a VSCode like extension is not running as root. It's very, very unlikely that you have like basically the setup where you have here the VS Code client running as user, and you have like a language server running as root. Could happen, but it's very, very unlikely based on my experience of having seen lots of software projects. But if that would be the case, if you have a language server running as root and a VS Code client running as user, then again, a malicious application could, of course, also maybe use IPC to talk to the server. So, yeah. But it could be worth investigating. Like, this is security research. You're now investigating, okay, so I have this idea. What if a language server is running as root? Could another local program communicate to the server and maybe does something bad? There's a lot of ifs, of course, involved, but so it's probably unlikely or something. But, and I want to look at a little bit something related but different. I have here, it's not dependency confusion, we are talking about like actually looking at the code. So the thing is, what different transports, so this is like my question, like what are the different, if we identified now that communication is important between the components, and we want to make sure that this communication is like not exposing dangerous threat surface, what kind of transports does this support? And so we can look, now we come back to the source code of the language server, we can look into here. So for example, we see here there's a transport kind IPC. So let's just search for this and maybe we can find like where this kind of code is. So there's, for example, a main TS file where it checks like the transport. There's also extension transport. So let's look in here. Oh, by the way, so this is, for example, a test file. This is always annoying. So usually when I search and I do code review, I always exclude the tests. It can be very helpful to look at tests, but then I specifically seek out tests. Hello, can you please exclude? Okay, no. So I can only focus on like the actual like relevant code. So yeah, we have here a few. So what do we have here? Get server working directory. So you can see here it does assemble here arguments. Pushes client process ID, it pushes here arguments, and then it spawns a client process. Because as you remember, the language server, works by spawning, a server process. The VS Code client spawns another process as a language server, which can then run separately and can do its expensive calculations and something. Okay, here we can get a glimpse of what the different transport mechanisms are. So we have IPC, and it uses here node IPC. I do wonder, is this like a standard thing? Node IPC. So is there like we can check like, is this what it's using it? And then I guess we can like look for the oh, this is the wrong window. We could like, we can like look for node IPC, and we can see it not being mentioned here. I was looking if there are like dependencies. Fix deadlock problem with node IPC. I guess it does use node IPC. Or maybe it doesn't need the dependency here in the code, because when you implement a server or client, you would then include it, and just like you make sure that the APIs are there, that node IPC is used. Transport kind stdio. So you can also have transport kind stdio. So if you spawn a process, you know, like in Python subprocess, in Python, when you like execute something, you can have like, you can capture like the standard out and standard in, right? Like maybe you have searched for this before, like how to run a process and get its output in your code. So you can read and write to the standard output and basically pipe, you know, and communicate this way. So you spawn a child process, and the child process is then reading from std in data and is writing data to std out. And this is like a perfect connection. So if you can read this std in and std out stuff, you can communicate with each other. Then it's a pipe, get random pipe name. So this is a VSCode language server protocol node. So here you see that pipes are dependent on the different operating systems. So it checks like if the operating system is Windows, then you create like this file. But what is XDG again? Ubuntu. Is this desktop manager stuff, right? I don't know. You can see like it depends on the operating system to use like these local files, socket files, like for inter-process communication, whatever, as pipes. What? I forgot it. Transport kind, not type. And then the other thing we have is if the socket is if the transport is a socket, a local port. And a local port becomes interesting because TCP is something a lot of things support, namely browsers and websites. HTTP is running over TCP. So having a local TCP port, now you come to the idea. So this is basically, this is basically what I noticed, that the transport can be listening on, on a local port. And the question is, can a website send malicious JSON RPC messages to a locally running transport? So first of all, we can do a quick check. So here's how it checks if the transport is a socket, and we can see that there's a transport kind socket. So what we can do is we can like I want code search. Okay. We can like look for repositories using that. How does this work? Code. So we can find here probably oh wow, this the search is crazy. Look at this. Transport kind code. It caught like, you know, like this enum and understood the context. That is awesome. Holy shit. That's crazy that it finds like this, because I was searching for transport kind.socket and it, you know. Anyway, you can see there are language extensions that specifically use and apparently like set up transport kind socket. So it's definitely something that is used. Maybe we can, like, if the idea works that I have, then maybe we can later start looking for extensions that use this, where we can see if it can be abused in some way, okay? So let's take maybe some notes. Different transport methods, IPC, node IPC, operating system pipes, SSD in out, and sockets, local port. And here is basically the research question. Can we target this local port from HTTP? Okay. So next, I guess, is let's see if we can change our example to use sockets. I have no clue if it's as easy as changing it like this. Debug, run debug, okay. I have no clue if that works. Let's see if, like, let's properly... Okay, let's relaunch this. Okay, it looks broken. God damn it. Okay, let's see. There's no output. So, okay, how do we get this now to work with sockets? Let's see, does the server, because I think the server does not create connection. Okay, maybe, okay, let's maybe take like one of these here. So this repository uses transport kind socket. Maybe we can find like the create connection. There's no create connection here. Okay. Okay, I was hoping this would just work. So here it sets up. Oh, the net connect. Oh yeah, this is like how socket. This looks familiar. As I said, like I've looked at another extension that was using that stuff. So this does look familiar. So I guess we need to import. So this is now the. Is that now the client or the server? I guess it's the client. So in the client, or is it the client? Find free port, listen, check Java. Okay, maybe there's a bit more involved. here you see a good example. So here it appears that they are using Fusion LSP server. So the server is maybe a binary, maybe not even implemented in Node. It's just integrating into, so, and here they are executing. Oh yeah, it's Java, it's implemented in Java. So this Fusion LSP server is implemented in Java, and they are executing, you know, the jar. And they pass in the port. So they say, please listen on this port, and then the client will connect to that port. How can we easily get this? Or maybe we just use, you know, we just use this. You know what? Why not just use this? What even is this? Which is Fusion programming language. Never heard of it. Oh my gosh, this looks crazy. I want just a very basic one. Just a very basic one. Okay, so let's see. Activate net dot okay, so maybe we just steal this find free port function as a start. So we are in the client. So we need to import net. Yeah, everything is going fine, I guess. I just try to implement now net has no default export. Do I need to like npm install net? Oh, I'm such a Node.js noob. Did that do it? Did that do it? Crap. Is that not a default? Import as... Oh, yeah, I could have kind of like copied the... Like, is this like different Node.js versions, like future stuff or something? I don't know. And what is like bad here? Oh, mixed spaces and tabs. Okay, so find free port. So how is this then used here? Get spawn args. Oh, this is all async stuff. Where is this used? It's calling start. It then calls child process spawn. Net connect language server port. Here it's creating the server options, but do I was hoping like that it would magically work. Like if I tell it, oh, use this transport, then it passes these options to the server, and the server will just do it. But I guess it doesn't work. Doesn't work this way. And I guess I should also in the server somehow probably like have to tell it like. It's probably more okay. Maybe it's easier if you use an existing project. This fusion thing just scares me though. Can we find a easier project? Maybe something smaller. Maybe it is. Well, maybe I shouldn't. VSCode language server node socket transport. This looks like an example. Is that an example? Code converter. What am I looking at here? Oh, this is just a fork. Wolfram kernel. VSCode auto hotkey. What is that? Auto hotkey v2 language support using VSCode LSP. Okay, yeah, that could be interesting. Okay, so let's have a brief look at here the code before we try to set it up. So we have the server TS, create connection. So are there now any reference to socket or port in here? No. And then the client, is that for sure? Server module, so it has like the path to the server module. Oh, in debug mode it uses socket. But good to know. I mean, we can or will start in debug mode. That's fine. But interesting. Can we not adapt this? So in the client code, let's remove that again. So we have here the server module, and then maybe we have to specify a port, maybe transport. Like this, maybe. Same down here. Then we could specify options, okay. And then I don't know, why would this not work? Oh, now it worked. Now it seems to work again. And I have socket. Okay, so do we have now? How do I check on Windows what are? Okay, let's ask ChatGPT. So I go into CMD. And then apparently I execute this. 1219. I'm not seeing it. Revert this again. I just want to make sure, like, okay, it seems to work. So there should there not be like a local port now socket running? Or does it like default back to something? Okay. You don't see it here either, right? Oh no, there it is. Okay. 1, 2. Okay, maybe, I don't know. Okay, there seems to be it. So we have, is this the process ID? Task manager. Process ID. Can I like view? Expand all. So where's VSCode? So this should be, yeah, this is a VSCode process and this is a VSCode process. Okay, so yeah, so we have it listening there. So now is the question. Okay, so let me think. I would like to observe this traffic. Can we, does Wireshark, with Wireshark, can we check this local host traffic? I know that on Mac, for example, you couldn't do that, but maybe on Windows, this works. Let's get the loop back. Let me, I guess, let's make some changes here. So now we should have lots of traffic. Oh yeah, JSON RPC, there we see it. Okay, cool. Stop. Okay, so here we can see now the communication between, no, okay. Can we, I guess, can we, how could we filter for this? It's just TCP, I guess. Or port 1, what was the port? 1219. TCP port. Why can I wait? Equal? Yeah. All right. Okay. So here, we can like follow TCP stream. Okay. So here we see how the whole communication like looks like. We have a content length followed by the data, and then we have content length followed by the data. So this is back and forth, I guess. Entire conversation. Yeah, red is client, blue is server. Because it's empty. It probably won't listen on 000. Yeah, that you're right, it won't, but this is, so if we speak about thread surface again, listening on 000 is of course nice because that means other devices on the same network, because you're listening on all interfaces, you can like connect to it from remote basically, which is again even more interesting attack surface. But this is still attack surface for the browser. We can still from the browser send connect to this local port. If you open a website and it sends like an HTTP request to 127, it's still fine. So that thread surface still works. Okay, yeah. Anyway, here you can see like, okay, the client sent to the server, hey, this document changed. The content that changed started like, in this range here, blah, blah. And then our server analyzed it and sent back the diagnostics. And I guess it says here with a severity of 2 starting in line 2 at character 27 to character 29. the message is OS is all uppercase. And this is exactly what we see here. OS is all uppercase. So yeah, this is the communication between the language, the VS Code extension client and the language server. Cool. So what I guess what's important to note is in which direction this communication is going. So like, is the server listening or is the client listening? So the first message was document change. So the method here, the RPC method here, is that the document has changed. So this is the client sending it to the language server. So, and we have port 1219 sending it to port 59846, which means the client is listening and the server connected to the client, right? Is my reasoning correct? So we can add client is listening, language server connects to it. Is that correct what I'm saying? On the other hand, the diagnostics. So here's the JSON RPC method text document publish diagnostics, and it's sent from this other port to 1219. Okay, so the VS Code client is listening. So I guess next is I would like to create. Do I have Python? Please let me have Python. Okay, we have Python. Cool. So let's create a small Python test. ChatGPT, create a Python 3 program to connect to TCP port 1219. 1219 and send this data. Do we have like a shorter message? TypeScript, insert text format, TypeScript documentation. Yo, Nassim, thank you for the Prime sub. Okay, whatever. Let's just take. Well, let's actually. So we can catch the communication from the start. Let's actually restart TCP port 1219, and then we completely restart this. Method exit. Okay, so we have it started now, I guess. Let's restart again. Runtime context destroyed. Gibberish. Okay, wait. Let's completely stop. Okay, so like this. So it's empty, and then we launch, and we get the diagnostics. Okay. This is not. Why do we not now get any messages anymore? Why am I not? Oh man, is this buggy? Listening for loopback messages. Or did it maybe connect to a different port because the port was taken or something? So, okay, clean slate. We launch the client. And we make a change. And I guess, yeah, okay. And then we stop here. Let's look again. WebSocket, that's something else. Okay, so here's the JSON RPC. .1219. Okay, so TCP.port.1219. All right. Okay, so here we have it again. Follow TCP stream. Okay, so here we have it. Here's the initialize. So this was sent from the server to the client. Or was this? No, shouldn't like this config data be sent from the client to the server? It's sent from it's sent from 1219 to the language server. Okay, yeah. So this means it's going to the server, not coming from the server. All right. Okay, yeah. So the client sends that over, and then the server responds with whatever data, and then. Okay, yeah. Good to know. Let's maybe make. Am I still listening? No. Okay. Let's do this again because I want like a very small test case. ASD. Okay, so now we have a very short diagnostics. The empty diagnostics. Yeah, okay, so let's grab that. And we can pause this. Let's go back to ChatGPT. Oh, what's your problem? Oh, this is wrong. This is not all the data. We need the content length as well. And then so after the content length we have DADA, RN. So RN, basically new lines, data. Okay. Oh, I think this will not work, by the way. Okay, so see, we couldn't connect to it. Connection refused error. So, is there like netcat installed? No, okay. We could. I mean, as I said, I played around with this already. A little bit. Let me see, what could I do? Looking back at the netstat, didn't it stop listening after connection was established? Oh, good question. We could basically execute it now. So, oh yeah, it stopped listening. You are correct. It's established now. It's an established connection. Correct. Very observant. Very good. I would have not caught this because I was like so blind to it. But yeah, you're absolutely right. And that is true. I knew that basically, but yeah. So I will talk about this in a moment. Why, or we can also like. I wanna see if let's see if we can like if we execute like this program here. Now it keeps always trying. And let's restart. Connection reset error, interesting. I wonder if that is the correct. How can I make multiple ones here in Python? Is it like accept? No, that's not how it works, right? I'm an idiot. Okay, whatever. Ugly code always wins. So we got a response here. We did read something here. And the extension itself said connection to server error, shutting down server. So it couldn't, there was, now you also see no highlighting and stuff. So let's do this again. Okay, so we got here a content length response. I wonder, so what was here this text message? So what do we have here? Line ASD is all uppercase. Let's change this to XXX so we can, let's see. I want to see basically if we can like inject like our own message there. Okay, so let's start this again and then refresh this. Okay, that did not work, but also we didn't win it. I guess we have to retry it until we get like here, we see a response. Okay, now. Yeah, it didn't work, but I'm also not sure if it would, like in this case, work. It could be that after the connection fails here, after the exit, it will like restart the server and then get the correct information. So maybe if we keep the connection open and not immediately exit, maybe that works. Output, we can maybe also see extension host. Pending response rejected since connection disposed. I feel like the reason why we don't see this because like, yeah, How difficult is it to implement your own protocol? Because the thing is, you can also implement like your own messages and stuff, and then it would be easier to like. Okay, let's see if we can quickly figure out how to implement like your own protocol message. That would be cool. It would be nice to have like a, you know, a JSON RPC handler. Maybe we can. So this is the JSON RPC code connection on notification. So this is the server side, child side. So here it's implementing child process. The client does have a connection thing. No, server, client options, client start, client dot on notification. Let's see if this. I define like a notification type here. Const, okay. So now we have like new RPC. expect one type argument but got two. What is gray shake? What is it supposed to be? ID string. Okay, so here somebody Julia extension. But you can see here also, you know, people implement their own like protocol stuff. I guess we do just string. And then on the server, maybe when we do like, when we validate the document, now we send such a notification. Can we do that? So that would be connect RPC. How do we connection or notification? Connection send notification. So here we have a notification. So I think we should just be able to, I guess we define the same notification type here, and we need to include this RPC thing. Oh, it's ChatGPT prompt injection stuff. Yeah, that sounds cool. Remind me if I don't forget when we finish this up, and then have a quick look at it afterwards. Okay, so hopefully this works. Let's restart. Maybe we can also set breakpoints here. On the other hand, let's look at the debug output. Where would that output come out? In the debug console? Oh, hello world. So we printed hello world. So this seems to have worked. Yeah, it's coming out. Okay, cool. So then let's use Wireshark again to observe this. So let's restart this. And hello world. So here we see a JSON RPC message with our hello world. Where is it? Here. So test notification hello world. So if we take that now, and this was sent, yeah, 21219. All right. Where did my code go? And then we change this 2, 3, 4, 5. 1, 2, 3, 4, 5. So the content length, of course, has to match. So that should be fine. So that is 70 characters. You can see it like down here. 70 characters. All good. Okay, let's test this again. Basically, we want to run this and then try to reconnect. Restart, I mean. Okay, so apparently, okay, now it threw also a lot of errors here. Hello world. Pending response rejected. I think I remember there needs to be a delay. It's like just wait like a second or something. It seems something else is happening. So now we get the initialize because we are waiting long enough. Receive. Is there like a receive all? I forgot. I guess not. Yeah, it has no option receive all. How do we do this? Time, sleep, I don't know. Oh, with socket, of course. Oh, I'm an idiot. After that, it disposes of the socket. So we should put that in here like this. So that we are not immediately closing the socket. Yeah, okay. Then we can maybe, yeah, let's leave it there. It's fine. Okay, so we'll restart the Python program. It seemed to have worked, but no output. And if we kill the socket, then it fails. And now there's a regular hello world test notification. Maybe it's the wrong output that we are seeing here. Maybe it's it's maybe send notification. Okay, let's just try it a couple of times. Maybe just unlucky. And let's maybe observe also the traffic, what's happening there. Why does now... Why does Wireshark not catch this now? Oh, the filter was not applied, never mind. So, okay, let's restart this again. So this is now a normal run. We see the hello test. All right, okay. And now we run our Python and execute it again. Connection refused. Okay. So we have here okay. So up here, let's compare these TCP streams. This is annoying that it always like changes the filter when you follow a TCP stream. I just want this nice TCP view here. Okay. So to the right is the one that is normal for the extension, and the left one is our test. So okay. So after the server sent this this initialize method, blah 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 blah, we immediately sent our test notification, while here there were information about the, oh, we responded to the initialize. So we basically sent back our capabilities. And then after that, we register our capabilities. I don't know if that's important, but let's add this to our Python. Init response. And then we send the init response plus the data. Let's see if that works. Okay, why am I not seeing anything now again in Wireshark? Let's try this again. Oh, the debug console worked. Hello XXX. Okay, so there's basically a race condition where you have a short amount where you can send you know, where you can quickly connect to the server before the, okay. Earlier in chat, who was it? About the established, Terras mentioned that. So the VSCode client starts a TCP server, and then the Twitch ads bullied you. Thank you. I'm glad. You know, in some way I bullied you and you gave me your money. It's like on a you know, on a school, in school, when like the bully walks up and wants your lunch money. That's basically what I did. I enabled ads, bullied you into subbing. But with Twitch Prime, of course, you can do it for free. Yeah, so thank you. 2 months in a row as well. Thank you. All right. Okay. So the VS Code extension client starts a TCP server, and then starts the language server, which connects to the client. Which again is I just realized it's funny regarding the client and like what is a server video, where the language server is actually acting as a TCP client connecting to the client, which is actually acting, you know, you implementing a TCP server. Yeah. And thanks, Wind Shadow for the tier 1 sub, also 2 months. Thank you. So anyway, when the VS Code extension and language server are starting up, getting initialized, they listen on the port, wait for the language server to connect to it, and that's done. Like, it's not a TCP server like a web server that keeps listening and allows multiple clients to connect. It allows one client to connect. This language server then connects to it, connection established, fine. This is already like a good design. Like, let's for a moment, like, there's no reason why you would want to allow multiple clients. Somewhere in the documentation, I also briefly saw that somewhere. I'm not sure if I would find it again, but it makes sense that you only want to allow one connection because you have the VSCode extension and the language server matching one-to-one relationship. It's not like a web server with multiple clients. So it makes total sense. And already that lowers the threat surface a lot because there's not a process just listening. There's only this TCP port listening in a brief moment. And this is when the extension is launched. So basically when you open up VSCode, when you open up your VSCode project with that VSCode extension, only in that moment it launches the language server and the client and it has this moment open. So already, this is mitigating a lot of risk. Like even if that would lead to remote code execution, let's say you could send JSON RPC from a website to this thing. Now you need a website that is open, constantly trying to send it, and somebody has to in that moment open and launch the VS Code client that initializes then, and then you have to win the race against the language server itself trying to connect to the port. Like lots of ifs and ifs that make this very impractical, so to say. So already like it's not a big deal. Regardless, you can win this race and send arbitrary messages. And here's like an example. We did this. We sent this message, hello XXX, with our Python program. But from a Python program, this is not an issue right now, not a problem at all, because we are connecting to this is also interesting. Earlier I mentioned, I'm basically just brainstorming out loud, right? So I'm not like telling you, I'm just brainstorming. Earlier I mentioned like, I drew this wrong. I mentioned what if the language server is running as root and you can quickly connect to it. But this is not the case. Even if the language server would run as root, actually the communication goes this way. Here, so there's no connection this way. You can connect to the client, and so already this is even more mitigating issues, because even if you would have your language server running as root, the language server wants to connect to a server and then get instructions on what to do. So a malicious website cannot open a local TCP port and trick the language server in connecting to itself, right? So this would only be like for a local attacker. Like you get what I mean? Yeah. So a malicious, yeah. Okay. How does it work when you open another editor with a different client? Does it start another instance of the server? Yes. And now actually in this case, I'm not so sure, because it's like one port. I think maybe in this case it would even fail in a second window, because like the port is already taken. Oh, no, it makes no sense. There's nothing listening right now. So a new editor will also just listen, wait for its language server to connect, and then they are not listening anymore. So yeah, they will spawn their own processes. But the real question is now, and this is basically what this all comes down to, the question is, can we send malicious JSON RPC from a browser? And this is where like the real like attack surface kind of like discovery kind of like starts for me. Like what I find interesting. Could we, because we wrote a Python program, but could we send this with a HTTP request? So we can basically test this. We can turn this into an HTTP request, right? We could, for example, we know how an HTTP request looks like. Let's maybe open here the browser. Is Wireshark still listening? Yeah, it's still listening. So in Wireshark we could like localhost this port test. Oh, it's not listening. Is it listening? Hey, Wireshark, you are really annoying me. Or does it only work if there's actually something listening? I guess that makes sense. No, wouldn't we still be able to see the synth packet going out? But it's not capturing anything right now. Okay. Hello, Wireshark, what's your problem? Can you capture anything? Oh, I have a pcap open somehow accidentally. God damn it. Loopback. Okay. Capture. Now we see stuff. All right. Yeah, of course, I guess we won't see the full request here. Do I have PHP installed? PHP? No. Python 3. Okay. Was it server.http? EA? No. Was it http.server? Awesome. I'm such a pro. Okay, so if we send like to port 8080 this test request here, we should see here the HTTP request, which is just a TCP message, right? Just with a different format. Follow TCP stream. So like here we can compare this, right? So this is the JSON RPC stuff, and this is HTTP. So this is what a browser can send, and this is what the VS Code extension expects. Lozok, here's a quick clip explaining a little bit what we're doing. So the question is now, can we basically, craft an HTTP request that works as a JSON RPC message? And basically, I guess we can like copy here a few lines just to emulate like we are just testing. We are just emulating here. Let's make like HTTP equal so for example we have get test HTTP 101 host localhost 8080 yeah, and then new lines, I guess, and then comes the content length and then the JSON RPC, and we prepend this now, and we act like as if that's like the HTTP request. And now let's see if that works. We start our Python program, and we check here, and we restart. So it worked, we connected, but we didn't get a message. So let's, yeah, okay. So did I listen on, yeah, okay, perfect. Let's have a compare this. Follow TCP stream, is that the correct one? Uh-oh, Wireshark is, oh my gosh, Wireshark crashed. Okay, it didn't work. So now we go into the VS Code implementation, specifically the JSON RPC parsing. So let's have a look how the parsing works and see if it helps us. Having Wireshark would be good. Let's open it up again. Okay, so let's make a quick, so let's capture traffic for an actual connection where we send hello test, and then we start our Python program. You cannot see, sorry. Okay, so we won the race. Now we can like look here, TCP port. Let's find our 2.1. So the first one here, this one should be the correct one. So this is the legit one. So this is the JSON RPC messages back and forth between the real VS Code extension and the real language server. We see here the back and forth, and we can in here also see here the test notification with hello test. So this is the interesting message to us right now. And after that, we tried this is exit. Let's try this here. So this was our test. And here we didn't get anything. So yeah, let's remove the HTTP part again to test it. Let's see here. Okay, so here is our test without the HTTP. I should have not. Oh, okay, so here's the original one. Here was the test. Here is our test with a Python program, just sending a minimal. So we get the same initial message, you know, the big blue message there. And then afterwards we sent like a response with our capabilities. Basically, that's the same as we do here. And then we sent the test notification, and that worked. So here in the debug console, we can see that we sent the hello XX. So with our Python program. Then we added like a HTTP header to it, like as if we would send this data from a HTTP request, and that didn't work. Because that is, I guess, invalid. Maybe did we see like here debug output? But either way, now basically the question is, can we craft an HTTP request that is actually valid JSON RPC? And for that, we want to look at the source code of JSON RPC. And a good start is we know that JSON RPC uses a content length, right? Like it uses here a content length. So this is like a very like a clear word, a statement that it's using. So we can search for that. And 1 second really quick. Sorry, back, and I stopped the music, I'm sorry. Maybe you can use the Gopher protocol. It's working to make SSRF to Redis server. But the browser doesn't support Gopher, I think. We are typically talking here in the sense where you use like curl or something, like where a server code uses curl to make requests, and then you can use like maybe interesting protocols like Gopher. But yeah. It's like the setup where you know what I mean? Okay, anyway, so we can look for content length. So we were now looking, you know, we want to look at the JSON RPC parsing of the content length of the JSON RPC messages, and we know content length is like an important word, so we can probably find stuff in here. And immediately we find here the message reader. So in this case, I've looked at this code before. That's why I'm more like telling you instead of like actually like searching myself. So there's this message reader implementation, and in here we can see that on data, it calls like this function on the buffer, try read headers, and then it it gets the content length header. And you know, earlier I made this tweet here. During a recent code review, I noticed something in the VSCode language server JSON RPC implementation that made my brain tingle. And this is what made my brain tingle, okay? So this is the moment. Because apparently there's support for multiple headers. Content length is just one header. It's not like the parser appears to not be, I expect a content length, colon, a number, and then text. It's like, I expect headers, and one of those headers can be content length, and then the message. So if we look into the try read headers, why can I not jump there? So let's search for that implementation. So it has here parsing code, character return line feed. So it has here state, you know, it goes like character for character and parse the headers and adds them to this, the lowercase version, you know, to the headers. It has like this map of headers. And this is then what I tested. So let's go back to our code. Let's say, okay, let's ignore the first line. Okay, we know this first line is not a header, but can there be just other headers, like a host header? And can there be like, you know, like ASD foobar, something like this, you know, like fake headers, basically. Let's try this. So we launch our Python code and let's have a observe like the debug console if we can get our, yeah, it worked. It worked. So we can send like anything here. As long as it's headers. And now, do you have an idea? Do you have an idea how we can make an HTTP request to be a valid JSON RPC message? Can you do it? Did anybody pay attention? And can you do it? How can we turn this in an actual valid JSON RPC message? So we know it supports headers. So basically, if you ignore this, here I'm covering it with my hand, which makes no sense. Okay. So if you just look at this, basically, this worked. This is a completely valid JSON RPC message that is allowed because it's doing header parsing. So how can we turn this? How can we turn a complete HTTP request into a valid JSON RPC? Exactly, Franz, correct. Nice to see you here. It's with a colon. So this is basically what I figured out, what I noticed, and that is what tingled my brain. So we can test this. So if we add back our fake or our like test starting point, and we do like colon test or something. Or actually I did like this, test colon. So it's like this is like the header name and this is the header value basically. Let's try this. To make sure we can also change, you know, here one letter. So let's okay, so this worked. So if we look here in Wireshark and we follow this TCP stream, this is the, I'm an idiot. Okay, all our previous tests were fail because I forgot to add HTTP again to the beginning. Okay, let's ignore that. Let's try this again. Please still work. Now if that doesn't, okay, it worked, okay. So here, you see here, Wireshark even recognized it now as HTTP. So this, I don't know why we don't see the response here. Maybe because like it's like weird. Or maybe we closed the connection again too quickly or something. I don't know. Either way, like it arrived here. Let's test it again just to make sure that. So yeah, ZXXX. ZXX, so this is the correct TCP stream. No, okay, here we get the full one. So we get, you know, this is what the server sends to us. And then we send back this HTTP request with some, you know, our fake header basically as the request, HTTP request line with arbitrary headers. There can be anything. And then important part is the content length and then our like response and test notification. Now, yeah, so theoretically we can use HTTP requests to send here. Does it check for space? I actually not sure. I always like tested it like this. I'm not sure if it requests the space. I guess we can test it. So let's do, you know, what Franz suggested. Put it in the front here. Let's see if that still works. Okay, this also worked. You can stay here. Oh, what is it? I could have eaten noodles. Thank you. I was brought food. I haven't eaten anything today. Oh. I'm so hungry. Cool. First problem solved. However, the second problem is, and actually I don't know if that works. The problem is that as far as we tested, we need to send 2 JSON RPC messages. We first need to send the response to the initialization, and then we can send our test notification. Because I think if you remove the init response, here, let's try that. I think it will fail. At least earlier it failed. Let's test this again just to make sure this. Yeah, I mean, here it succeeded, but we don't get the debug output. So we need 2 JSON RPC messages. So the question is now whether it's feasible to do this actually from the browser. Will the browser help us and do like HTTP pipelining? Like, can we get the same TCP connection to send out both requests? Does that work? Does anybody know? I actually haven't like explored HTTP browser stuff like this deeply, I guess, in the browser. If you send like use fetch or something to send like 2 requests like at the same time, basically, will the browser help us and send this over one TCP connection? So that's basically what we need to test next. So let's Python 3 HTTP server. So let's create a new index.html. So we have now here our test website, and then we want to do like some script, and then fetch okay. Right. Send HTTP post request with plain text using fetch. Is the browser able to pass the response, or would the timeout waiting for a proper execution? Exactly, it would probably time out, or like we will not be able to get the response, I'm pretty sure. Because it's not a valid HTTP response, like with, you know, the status code at the top, it's like not, it's not okay. So of course it's like not like you can steal, like talk actually to the extension and like do like interesting stuff, you know. But yeah, so let's see if that works. Okay, so the URL would then be, what was the port again? And then we need the fake header, so test : that would, you know, turn into into this line here. And then as body data, I guess we create a function here. Data. And then we wanna send this data. Now the browser will make the content length for us, so that's not a concern when we send the request. But send this, and then we want to send our notification. So will the browser do now like pipelining stuff if we send it like this? I guess we want set timeout. We want to like basically execute this in a loop now anyway, like set interval. I have no clue like what will happen now. We will see. Okay, so when we now execute this, course request did not succeed. Okay, we want no course. How do I do this? Course? Was it like this? Course, no course. I guess we don't want the response and stuff anyway like this. Mode was it? Does this work? Will the request be sent out? I think it will be sent out, right? Like it seems to keep sending that at... Okay, let's see what just happens if we like relaunch the... And I guess we can check in Wireshark as well. Okay, we don't see an output, which is an indication that one connection succeeded, I think. Because like it's waiting now on stuff, maybe. How can I like filter out these invalid TCP? I guess I can filter for not RST. Does it work? And TCP dot flags. Oh, Wireshark crashed again. Both requests are sent at the same time in this code. Don't you want to chain them? Yes, but I hope the browser will do that for us. Like that the browser recognizes, oh, there are two requests going to the same host. Now we're going to pipeline them. I don't know if that works. Like I've never like played around with that. Isn't that something to specify on the server? That's a good question. I actually have no clue. I mean, if that doesn't work, then I guess the whole attack idea, like the whole research then was kind of like fail. I feel for HTTP 1 it won't do that. Isn't that... let's see, maybe we can like answer this question. Chrome HTTP 1. I'm sure we're like with request smuggling during that for that research didn't they look into stuff like this? A keep alive connection is implicit with each HTTP 1. And we need an explicit content length, which we also have. If an origin has successfully pipelined before it's remembered and pipelining can begin automatically. I feel like one request has to succeed first once, and then after that pipelining could be maybe used. I mean, all these responses, all this stuff kind of like is fine, but the problem is we obviously don't get a response. Like we need one successful request, and after that pipelining is like enabled. I'm eating like bread with salad and vegan. Okay, there's not even pipelining. Doing so currently requires a custom build of Chromium to enable pipelining. So this is not even a thing anymore. Fuck. Well, I guess in the end we can conclude failed research. To be honest, I kind of expected it. But it's okay. We could try smuggling. You would obviously do smuggling not from the browser, but you know, you have like a burp or something where you actually control carefully the request and then send them to, like if you would be able to do that, then of course like we can target this port. But the question is if we can do it from the browser. DNS rebinding is, yeah. I mean, if pipelining is not supported at all, then I mean all of that is moot. And the problem is with the header. So the thing is, right? So let's look at this. Basically, we want two messages, right? We want for demonstration purposes, you know, obviously the content would be here at the end, no new line, but for demonstration, let's just add it here. So we control the body of the request. The problem is that if you would send like all of this as a body, that would be 265 characters. Then it would be like this. And now it interprets this all as a message, and that is probably then invalid JSON and the RPC would fail. But theoretically, you know, if we could have a small content length here and then we control the body, we could have here anything. So, but maybe we can smuggle like, no, wait, we can't with fetch, we cannot control other headers. I mean, we could look at the header parsing again. You know, if we could smuggle in, I mean, is kind of like request smuggling. If like we could, I don't know, can you control any X header like with fetch, even with not cores? Does that work? And then maybe something like this would be accepted as a content length header. Can we trick the header parser to take a different header as the real content? Yeah, that would be the idea. Okay, so I haven't actually looked at the header parsing code. I mean, if anybody wants to follow along, can I share like a link right to this file here? Does that work? Copy GitHub permalink. So this is the code if anybody wants to like have a look at it as well. So this is the message buffer object that implements the try read headers. So in the message reader, the data is coming in. It appends this data to the buffer, and then we have a while true loop. There's nothing at the end. So then we have some if cases. So in this if, it checks next message length is, I guess, not set. I guess that's what -1 maybe means. And then so if message length is not set yet, it tries to read headers, tries to get the content length, parse the content length, and then sets this as the length. And then after that, it reads like, try to read the whole body. And if we haven't received the full message yet, we set a partial message timer to maybe try in a moment again. I don't know. It's also like interesting, weird stuff. I don't know. Remus MC, thanks for the tier 1 sub. Content decoder, decode the body. Okay, so here they decode content type decoder. Interesting. So maybe this options is passed in bytes, content options, content. Does it maybe even support different content types as well? Alright, let's have a first look at the header parsing. Okay, chunk index, chunk. So we go through the whole chunk index. So we read one character. No, we don't. What is this? Chunks. Okay, this is, append. Okay, so chunks is, okay. Wow, it does not append it to one like long thing, but it like it's a list of bytes. Like a list of bytes, you know what I mean? Are you sure that content length takes the first one? No, but we cannot set a different content length, I believe. Like you in fetch, like from the browser, we couldn't like set a custom header length, content length header, I believe. Pretty sure. I wouldn't even test it because I'm so sure, but maybe you can prove me wrong. Okay, so we pick a chunk and then we loop over that chunk Then we have a state machine. If we have a carriage return, now it would be nice to, okay, we start in state 0. So if we state 0, we go in state 1. It's always carriage return line feed, carriage return line feed. So let's see if like leading carriage return line feeds are ignored. There would be, so we are in state 1, and then would next iteration would come a line feed. If it's case, then we go in state 2. Where does it like take the state then out? I mean, while row, while chunk. Because like as soon as it reads like a not while offset, so it goes to the whole chunk. I mean, these state changes are then as soon as there's another character again, it's in state 0 again. Oh, it does want to be at the end in state 4. Okay, I don't know. My brain, I'm not good with reading, like understanding parsers. The buffer contains the tool control, so we will have 2 empty lines after split. There's too much to think for me right now. I will probably stop streaming soon as well. It was just like a small investigation I kind of wanted to make, and I'm already disappointed that it's not really leading anywhere. But it, you know, there's still a chance a little bit. I think it just wants to find the first time RN occurs. Yeah, possibly. Makes sense. Here it splits. Okay, so now it reads like a chunk as a splits it at the CRLF, and then looks at the index of the colon, and then it splits it up in key and value there, and then it does lowercase. Okay. I don't see a way. I don't see a way how a different like named header or anything. I mean, of course, except of course the casing, lowercase, uppercase and stuff. But even a space seems to like be like, it seems to be strict here, right? Because it splits at the colon. So if it's header name space colon, the space will be included and stuff, and then it doesn't match anymore. I explained a bit in this clip. And then read body just attempts to read this length. That would have been also been interesting if like the, I don't know, if you could smuggle like new header, like that it starts ignoring the length or something like this, but it just straight up wants the byte count here. Of course there are arrows if the total length is shorter. Oh, okay, wait. This is a bit interesting. Okay, so if the byte length is equal to the... Oh, yeah, okay. If the chunk... Okay, whatever, then we get like this chunk out. If the byte length is larger, then we carve out this data. And if that also is not the case, then we have a loop. Yeah, taking out everything. I mean, there's like, you know, I don't know, there could be like off by ones or something, I don't know, parsing in a weird case where like the byte count is like, where it's a very large message and it's split up, and then in the loop, then things break, and this is so rare that it never came up during testing or something. I mean, if I had a target now where I would know if I could solve this problem, I would have remote code execution or something, then I would be really, really motivated to dig in here very, very closely. But because the target, because I don't have like a specific target, and it doesn't seem to be like typical that controlling here one of these JSON RPC messages would lead to anything dangerous. It has to be something very weird. I lack the motivation, you know, to like look into this a bit more deeply. Too bad we can't use Flash anymore. I think there were some more options with pipelining back then. Yeah, no clue. I guess during that time of Flash times, I wasn't even thinking of HTTP pipelining. But with Flash, you could also control some headers and stuff. So that would, of course, would have been very interesting, if I remember correctly. Are there other, like I was also thinking of WebSockets, but I'm not sure. I think WebSockets can only be established after one regular HTTP request, where then you have the change protocol thing, right? Like it's not like you can just connect to a port and send like WebSocket messages. Upgrade, yeah, that's what it's called. Yeah. Anybody got any other ideas? I mean, that's basically what I wanted to investigate. I noticed that the header parsing, you know, you can like smuggle in that, you know, or get through like this header. Now, one other thing to mention, the extension I was actually looking at had JSON RPC messages, I believe, that worked before sending the response, because like they added like some kind of their own parsing before like the official VSCode initialization happened. Like they were like directly listening on the messages and handling something out. Like I believe there might be some extensions where like sending one message would work, but I don't know. Like I don't even know how we would be able to find this. You know, find such an extension, even if it does exist. And then again, you have like a lot of ifs. So if there's an extension that's using TCP as transport and not any of the other methods, and has a custom notification, custom JSON RPC method that does something bad, and it's implementing it in a way where you don't have to initialize the JSON RPC first, but like they are listening just like raw on something. I don't know. Can you send an array of objects? Actually, that's a good question. Yeah. Right, you're right. We should maybe check out how the body parsing like works. Maybe it supports like multiple. That's a good point. So here it reads the body. So what does it do with it? Then it passes it onto the content decoder. Content decoder. What is the message? How does a JSON RPC method look like? It has like, So maybe if we search for, this will probably come up a lot, but maybe we can find like where it reads these values, like these messages. It should also be implemented here, right? Capabilities, is that not also sent? Yeah, client capabilities, so this is definitely part of here. Does it use maybe even another, like I thought VSCode JSON, I didn't even look like encode. Okay, here's the content decoder and encoding. Get encoding header value. What is it doing here? What? What is that kind of calculation for? What? Parse encoding header. They have a different. I'm really confused right now. Parse encoding Q equal where did I see this again in HTTP requests? Q equal index of. That's so weird. I'm very confused right now. Or is that from the connection string maybe? Like I don't know. Encodings. No, it makes sense. What am I talking? Message reader. Decoder name. Looks like a thing found in accept header. Yeah, right. I definitely remember seeing. I couldn't quite put it where it was from. But why would it look at the accept header? Okay, this is like my typical problem when like code reviewing. I'm just like clicking through the files and hope something jumps out, which is so unproductive. But I'm trying to sort my thoughts. RAL message buffer encoding from string. I guess this is just like UTF. I mean, there must be like JSON.parse or something? Oh, there it is. What does RIL stand for? RIL. RAL. Response inline RAL. Respond. Either way, the JSON parsing here, what is this? Node? Oh, not browser. We want obviously Node. Files. What is this? Oh, this is no, this is something else. RIL extends RAL. Okay, I don't know how much this is bullshitting now. Runtime abstraction. Runtime interface layer and runtime abstraction layer. Okay, whatever this other stuff is, but that kind of makes sense, right? So one is the interface and one is the like the implementation itself, I guess. Where's the code? Okay, we have a JSON encoder, and then it just creates stringify and parse. I'm not quite sure, but I guess you have readable and writable stream, and then whatever you call. I cannot read this code. Like this is like I'm confused. Buffer decode. I guess a dynamic test makes more sense. So let's if we do like if we go in our test.py and or I guess in here and we send this in a list. Let's see what happens. Okay, so this is doing its thing. Received a message with neither a response nor a notification message. Yeah, okay, so this definitely failed, but I mean we did win the race from the browser, which is of course also another like question we had. But yeah, this received message which is neither, maybe we can find this in the code. Here, this is the error message. Handle invalid message. Okay, it's only handle message is request, is notification, is response. Message is request. Oh, I guess, yeah. Oh, no, the one thing is a response and the other is a request. Okay, it just checks if the method, the ID is there, or yeah, this kind of stuff. And yeah, we provided a list, and so that didn't match anymore. Maybe one JSON RPC object can contain multiple messages. Yeah, I mean this was, how would you do this? I mean the list you proposed was like basically that, right? But I don't know, result. So at least this check here on the received message, it wants explicitly a method and an ID or a result. So the first message is like this response. It's so unfortunate that they require this that you respond to the this first request. Yeah, if you don't respond with the to the initialization thing. Okay, anyway, I to me this is kind of like failed research now. That's fine. I think I will stop now anyway. I want to eat lunch. Any final thoughts? But maybe, maybe you feel motivated and you wanna you find this interesting yourself. You could look for VS Code extensions that use TCP transport. Look for extensions that use the transport kind socket, and then, yeah, I don't know. But it was fun. I would like to do more stuff like this. Just looking at random projects. I have another coding project I like to look into. And I wanted to be reminded of this one website there exactly. I really like to encourage people to do research. CTFs is that for me. It's like a little contained thing that you research and you try to find vulnerability. So I feel like security research, where you just take like a little library or some software or so, it's it's kind of the same thing. I feel like it's just like a small contained thing, and you can just explore and see what's possible. And in the end, depending on the kind of library you look into, it might be helpful. Like I really want to do this, for example, for Django or React or something, and then just document, these different ways that could go wrong. And then it could be like a repository for people to look. Oh, I'm auditing a Django project. Like, let's see like some weird quirks that could happen, or like something like this, And in this case, it is like research. I wonder how this could be like properly documented also, because like I feel like we figured something out about like the communication of VS Code and JSON RPC, which in this one idea we had, it didn't quite work, but maybe there's I don't know, like it's just, I don't know, like if anybody has ideas how this could be structured or something, I don't know. Yeah, maybe the idea is also maybe I can use this for live overflow videos. So now I did like the work, and maybe this could, it's like on my list of ideas of videos that I could work on. Basically this failed research, which I think is, if it's like like this was now 3.5 hours, but if it's like, or like around 3 hours, but if it's condensed down to a 10-minute video about like all the lessons learned and then the end, the failure, I feel like that's the kind of video I would like to watch, because like I like, research and investigations and stuff. Even if it fails at the end, I feel like there's always value to be derived, even if it's just like the methods used to investigate, and then somebody else can build on top of that. Maybe, they feel motivated and have other ideas they want to try and stuff like that. At work, we do a monthly use this bug of the month where everybody can share failed research. It's always fun. Oh yeah, that's really cool. I like failed research. Failed research is great. And you never know. Sometimes somebody else looking over it realizes that it's still possible also. Okay, cool. Yeah, thanks so much. And then see you soon. Bye-bye.